Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 4 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 1123. Lowest common ancestor of deepest leaves. Okay, so let's read the problem statement first. We have given the root of a binary tree. We have to return the lowest common ancestor of its deepest leaves. Okay, recall that the node of a binary tree is a leaf if and only if it has no children. Okay, the depth of the root of the tree is 0. Okay, so depth of the root of the tree is 0. If the depth of a node is d, the depth of each of its children is d plus 1. Okay, done. The lowest common ancestor of a set S of nodes is the node A with the largest depth such that every node in S is in the subtree with root A. Okay, so understand this line. The lowest common ancestor of a set S of nodes, okay, is the node A with the largest depth, right, such that every node in S is the subtree with root A. Okay, so now here see this example. Okay, this is a root given to us of a binary tree. Okay, so here it's like this 3, right, then 5 1. Okay, then we have 6208. Okay, so 6208, then we have null. Okay, so here for this 6 we have null, right, and here also null, and then we have 7 4. Okay, so this is how I have drawn this tree, okay, for this particular values, right? So this is done. Okay, now let me just revert these changes. Okay, so this is done. Okay, now after that we need to do here. First of all, for this 3, what is the depth? Okay, the depth of the root of the tree is 0. Okay, so 3's depth is 0. Then 5 1 depth is 1. Okay, so here what I'm writing depth. Okay, 6208 depth is 2. Okay, and this 7 4 depth is 3. All right, this is done. Okay, now from this diagram it is clear that these are my leaf nodes with the max depth. Okay, leaf nodes with max depth. Okay, so what we need to return here? Okay, so depth of the root of the tree is 0, and if the depth of node is d, the depth of each of its children is d plus 1. Okay, and you already know that node of binary tree is a leaf if and only if it has no children. And here the lowest common ancestor of a set S of nodes, okay, ancestor we have to return. Okay, if the node A with the largest depth such that every node in S is a subtree with root A. Okay, so what we have to return? We have to return this complete, okay, this complete part. Okay, so here my output is going to be 2 and the children of 2 7 and 4. Okay, so this is what we need to return. Okay, so leaf with the highest depth and its parent, we have to return that. Okay, so here if you see the explanation, we return the node with the value 2 colored in yellow in the diagram. Okay, the nodes colored in blue are the deepest leaf nodes of the tree. Note that nodes 6 0 and 8 are also leaf nodes. Okay, these are also leaf nodes, but the depth of them is 2, but the depth of node 7 and 4 is 3. Okay, so we have to find the leaf nodes with max depth and we have to return them along with their ancestor. Okay, so lowest common ancestor of the deepest leaves, so deepest leaves are 7 and 4, and the lowest common ancestor of them is nothing but 2. Okay, that's it. Okay, clear. Now let me just remove this few things. Okay, all right, now it's done. Okay, now after that, how I'm going to solve this problem? Okay, that's my next question. Okay, so what I'm going to do here, I'm going to use recursion. Okay, and going to call DFS here. Okay, how I'm going to call DFS? So what I'm going to do here? Okay, initially I'm going to start from here. Okay, from this node. Okay, and here inside this I will just iterate over to the left side. Okay, so here I will move to its left. Okay, this is done. Then I move to its left. Okay, done. Then after that I move to its left. Okay, I see that there is nothing. Okay, I see that there is nothing in this side. So what we have to return, so I'm just going to return the node. Okay, so here there is nothing now, so here I'm just returning node. That simply means you can say null. This is one thing that I'm going to return, and here from here I'm just going to return 0. Okay, since there is nothing. Okay, so here I am returning node and I am returning depth as 0. Okay, done. Now same way, after that I move to the right of this 6. Okay, so when I move to the right of 6, so from here also I need to return two things, and that two things are null. Okay, and the uh, here depth is 0. Okay, depth is 0 for this. Okay, this is what I'm going to return here. Okay, so I'm going to return null and 0. Okay, that's it. Now after that, this is for 6. Okay, so from 6 I am returning this and this. Okay, so here if you see, from 6 left side depth is 0. Okay, and 6 right side depth is also 0. Okay, so what I'm going to do, if left dot depth, okay, 6 is okay, if 6 depth to the left side and right side both are matching, then in that case what I'm going to return here from 6, I'm going to return the root is nothing but 6 this time, and the here I will just increment the depth. Okay, so depth I'm returning 0 0 from both sides, so here I'm returning 6 and 1 here. Okay, I have incremented depth by 1. Okay, so this is nothing but 1. Okay, 1. So this is what I'm going to return from here. Okay, so I have solved this part. Now come to fives. Okay, so here 5. Okay, so here I'm going to go to this right, then I'm going to go to this left. Okay, then after that for 7 I'm going to go to the depth. So from here also I'm going to return null and 0. Okay, from here also I'm going to return same thing, null and 0. Okay, same way I go to the 7th right. Okay, 7th right I have to go. Okay, let me use green color for that. Okay, 7th right I'm going to go, and then I'm going to return from here also what, null and 0. Okay, this is done. Then overall from 7 what I'm going to return, from 7 I'm going to return nothing but both having depth 0. Okay, so I'm just going to return 7, and here I'm just incrementing the depth by 1. Okay, 7 comma 1, this is what I'm going to return. Okay, 7 is nothing but a node. Same way you have to do here for right of this two. Okay, so you go here, then from the left and right both sides you are going to return null comma 0. Okay, and this 4 is going to return, 4 is a node. Okay, and depth is 0 plus 1. Okay, so here I'm returning 4 comma 1. Okay, this is done. Now for this two we already know both the parts. Okay, from here we are returning 7 1, and here we are returning 4 1. Okay, so from here also if you see depth is same. Okay, depth is same, depth is 1 here, here it is also 1. Okay, so from here also what I'm going to return, I'm going to return here, you can say this root. Okay, 2, and here you have to return depth plus 1. So depth is 1 here, 1 here, so 1 plus 1 2 here. Okay, you are returning 2 comma 2 here. This is done. Okay, 2 comma 2. All right, now here we know 5's left and 5's right. Okay, so from 5 left I am returning 6 comma 1, and from 5 right I am returning 2 comma 2. Okay, so now what I need to return from here, okay, so now see the depth of right side is greater, right? So here depth of right side is greater, so what you need to do in that case, you have to return from this 5 this root node. Okay, so if the depth of right node is greater, then you have to return right node. If the depth of left side is greater, then you have to return the left node. Okay, so here depth of right side is greater, right? This, so from here I'm returning this 2, and I'm incrementing the depth by 1. Okay, so 2 comma 3 I'm going to return from here. Okay, same way you have to solve this part. Okay, so you go into here right, then you have to check its left. Okay, then from here you have to check its left and right, so both are going to return null and 0 from here, and overall you are going to return 0 comma 1. Okay, 0 comma 1 here, and same way you have to go to its right, and then you have to check you have to go to its right, and then you have to check its left. Okay, then you have to check its right, then from both sides you will get null comma 0. Okay, and overall you are going to return here nothing but 8,1. Okay, now here at 1 what you are going to return, so both side depth is same. Okay, so you have to return this one only. Okay, this node then. Okay, and you have to just increment 2. Okay, so now for this 3 also you know both the things. Okay, for this 3 now, okay, let's this see this 3. Okay, so from here I am returning 2,3, and from here I am returning 1,2. Okay, so here see the depth of left is greater. Okay, so depth of right is just 2 and depth of left is 3. Okay, so in that case from this 3 what you are going to return, you are going to return this node now. Okay, left dot node. Okay, so left dot node is nothing but 2, and here the depth 3 plus 1, so you have to increment depth always. Okay, so 2,4. Okay, so you have to return this. Okay, 2,4. All right, so now in the end what we are left with, we are left with this is nothing but node. Okay, so for this node you have to apply the BFS. Okay, for this particular node only. Okay, so here this is a node, right? 2. Okay, and we have 2 children as here we have 7, and here we have 4. Okay, so now you have to just apply BFS on this. Okay, so that is nothing but you are going to return 2 and then you are going to return 7 and 4. Okay, so that is nothing but your output for this particular problem. Okay, so this is very simple, right? So I hope that you guys are clear how our recursion is going to work. Okay, now let's write the code. All right, so here let me just maximize the screen. Okay, so here what you need to do, okay, so here first you have to return result. Okay, so let's say 3 node, and here I am expecting some result. Okay, so I'm going to call one helper method. All right, and in the helper method I'm just going to pass first root. Okay, and here I'm just going to return node. Okay, for that node we will automatically get the complete BFS tree. Okay, so I will just return that node. Okay, that ancestor node having whose children as having highest depth. Okay, so that's what we need to do. Okay, so here let's add some debug print statements. Okay, so that you guys get clear idea. Okay, so no other tutorial on YouTube will add these debug statements. Okay, for this one, but let me show you. So here system dot out dot print ln. Okay, so here let's write LCA, lowest common ancestor value. Okay, so that is nothing but you can say you will get lowest common ancestor value as result dot val. Okay, so I will show you what is this result. Okay, so here let's write it result dot val. Okay, so it should print 2. Okay, in our particular example it should print 2. Okay, and then also we have to check for the right, left and right now, but there is condition like if there is no left child, then we don't have to print that, right? So let's add if condition here. If result dot left, okay, if result dot left is not equal to null, is not equal to null. Okay, so here actually in this example what I'm showing you why 7 and 4 is coming. Okay, so that's what I'm to show you. Okay, so here you have to write again, just copy this value here, print it. Okay, system.out.println, and here instead of LCA you have to write left value or left child, you can say. Okay, left child. Okay, so if left child is there, so we have to print that now. So left child, and here you have to write result.left.val. Okay, result dot, okay, you can write it like this, result.left.val. Okay, now same way here for left, and here you have to do for right. Okay, so these are optional lines. Okay, if you don't want to add in your code, no issues. Okay, result dot right is not equal to null, then system dot out dot println, here you have to write right child. Okay, and here you have to write result dot right dot val. Okay, so once these are just debug statements. Okay, optional. All right, and here from here just you have to return the result. Okay, that's it. All right, now this is done. Okay, so here if you see in my code what we are returning, we are returning two values, one is node and one is depth. Okay, so let's create one pair, or you can say class. We can create a class. Okay, let's name it as private. Okay, class result. Okay, let's say we have to create one helper class to return both depth and LC node, okay, lowest common ancestor node. Okay, so here I'm just going to create one class result. Okay, so I'm going to do the pairs, right? One is a node and one is a depth. Okay, so you can write here tree node, node, and you can say depth, so int depth. Okay, then create a constructor. Okay, so here you have to just return, write the same class name, and in that class name you have to just pass the two values. Okay, so tree node, and here after that you have to pass the depth. All right, and then you have to just assign the values. Okay, so this dot node is equal to node. Okay, this dot depth is equal to depth. All right, so now this result is having two values. Okay, so whenever I'm going to use this result, so I'm going to return two values, that is to a pair, okay, of a node and depth. All right, so this is done. Okay, so this is also done, easy. Now after that, final this helper a helper method. Okay, let's write the code for this. Okay, so this is also very simple. Whatever I explained here, I'm going to write the same thing. Okay, so private, and the return type is going to be result. Okay, this result, return type result having node and depth. Okay, so that is nothing but my return type. Okay, so in other code we write int boolean, so while writing the methods, right? So that simply means that that's their return type. Okay, so here result is the return type, simply means node and depth. Okay, so here helper, and here inside this, but you have to just pass the root. Okay, from where we are starting. So here I'm just going to pass the root. Okay, now here we have passed this root, right? Okay, now here inside this, what we need to do, first one base condition. Okay, if root is equal to null, so then what you guys were doing? Okay, so when our root was null, then you were returning null and 0. Okay, so that's the same thing I'm going to write here, return new result. Okay, and here I'm just going to return null and comma 0. That's it. Okay, now this is done. Then you have to check for left and right. Okay, so result left is equal to helper, and then you have to pass root dot left. Okay, and same way result right you have to write. Okay, and here helper root dot right. All right, and then after that you have to check if left dot depth, okay, is equal to right dot depth. Then what you are doing? Okay, if left dot depth is equal to right dot depth. Okay, so in that case you have to return new result. Okay, and in this you have to just pass the root and left dot depth plus 1. Okay, so you have to just increment the depth by 1 only, right? Always, right? And here in the else part, okay, else part, let's suppose my left dot depth is greater than the right dot depth. Okay, so in that case what we were doing here, so left dot depth is greater than right dot depth, then in that case we are returning this value. Okay, so this is nothing but the left side value. Okay, left side node, and incrementing depth by 1. Okay, so here I'm just going to write inside this, I'm just going to return new result, and here I'm just going to pass left dot node. Okay, left dot node, done. And here left dot depth plus 1. Okay, we have to increment the depth, left dot depth plus 1. Okay, so this is done. And in the else pass, okay, if the right dot depth is greater than the left dot depth, then in that case you have to return new result, and here you have to pass right dot node. Okay, and here you have to pass right dot depth plus 1. Okay, this is done. All right, now let's run the code and see if there are any code issue. We'll try to fix that. So all the test cases has been accepted. Okay, so here see, LCA value is coming as 2, left child value is coming as 7. Okay, and right child is coming as 4. Okay, so this 274 is my output. Okay, so let me just I hope that you guys are clear. Okay, so now let me just remove it. Okay, these are not required, this is just for your knowledge. Okay, so now here let's run it again. Okay, and now after that, let's submit it. So see, our solution is accepted, right? Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.